Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Hello and welcome to another episode of Lost in Science. It is your usual science that you come to expect and know and love, I hope. My name is Chris, and joining me as always, I have the lovely Stu. Stu, how are you?
I'm very well, and hopefully lovely. Not that anyone out there can see me. Yes, doing my best.
I didn't mean visually, Stu. Just lovely in general.
Just lovely. Yes, and yeah, I'm good. And I have a story this week. I'm going to get a little bit atomic. I'm going to be talking about nitrogen just because it came up as, something. It is a hugely important atom. Which is why I said I was going to get atomic. But it's one of the most essential atoms that we rely on to be alive, and all living things rely on nitrogen. But there's some interesting research going on around nitrogen and why it's important, and people looking at ways of making it more available and all sorts of things like that. So I'm going to talk about nitrogen, and nitrogen fixation is really what I'm focusing on. Yeah, it's good stuff, and it's all around us all the time, which is also very good as well.
Wow, sounds like you're the one with the nitrogen fixation, Stu.
Indeed, you could look at it that way. Yes.
Yeah. Well, me, I can't think of a smooth segue. I'm talking about death.
Well, a segue is that without nitrogen, we'd all be dead. How about that?
Okay, this is true.
Yeah.
Now, I'm talking about not quite death. I'm talking about near-death experiences and that sort of thing.
The old NDEs, as they're called in the trade. Yeah.
I guess the traditional view, we think of it as the light in the end of the tunnel sort of thing, that sort of spiritual experience. And a lot of people, I guess, have different views on what's happening there. What it means about the nature of life and existence and consciousness and this sort of thing. Well, there has been some new research kind of probing this area. It's not quite directly at NDEs, I suppose, this one, but it's a related thing. Looking at what happens in the brain when the heart stops beating. And showing there is surprising activity going on in the brain. It's another piece in the puzzle, but it's an interesting one. Let's not try not to disturb our listeners too much with this talk of brains shutting down and that sort of thing. But it is fascinating things. And like I said, people are fascinated by near-death experiences and what happens at that moment. So yeah, look, I thought I'd have a look at the science such as it is, and what we can say so far about what's going on.
Cool. Sounds amazing.
Yeah. Like it's heavy stuff, shall we say? All right. Well, on that cheerful note, on with the show.
One of the most important elements for life on Earth is the atom nitrogen. And when I'm talking about elements, I'm obviously not talking about the old-fashioned fire, earth, wind, water thing. But this is lucky because it's also one of the most abundant elements on Earth, and possibly it's so important for life because it's so abundant, or possibly life is so abundant because the nitrogen is there. It's hard to know which way that works. Either way, without nitrogen, there would be no ribonucleic acid or deoxyribonucleic acid, otherwise known as RNA and DNA, which are the assembly instructions and the workshop manual for living things, if you want to look at them in that way. Basically, nitrogen is absolutely essential for life to continue as we know it. And as I said, luckily, about 80% of the atmosphere is nitrogen. So
yeah, but hang on. There's a problem there, isn't there, though, with the nitrogen that's in the atmosphere? I mean, there's a lot of it there, don't get me wrong.
yeah, heaps.
But there's a problem with it, isn't there?
Well, there is. It's a gas, and in that form, not all that useful for most living organisms. So in order for it to be useful, it needs to be converted into a form that living things can use. And the easiest way to do that is to convert it into ammonium, which humans figured out how to do that in the early 20th century on a large scale. That actually allowed us to make nitrogen fertilizer out of air, which led to the population growing from about 1.5 billion people to the current 8 billion people that we have. And perhaps, ironically, the reason nitrogen synthesis was developed by humans was not to grow farm crops, but to make explosives to reduce the population. That's another story. I think I've told that before on Lost in Science.
I think you have.
But, it is a sort of irony there that the impetus to develop that technology was not actually to grow food, but in fact to kill each other. Anyway, millions of years before humans were trying to kill each other in ever more destructive ways, other living things were trying to survive in the harsh environment of a young planet. And some of these organisms evolved to be able to take nitrogen gas from the atmosphere, which is in the form of N2, or basically two nitrogen atoms stuck together, and they turn it into ammonium, or NH4, which is one nitrogen atom stuck to 4 hydrogen atoms. So it's a different chemical form of nitrogen. The means to do this is by way of a specific enzyme called nitrogenase, which splits the nitrogen gas and binds each nitrogen atom with 4 hydrogen atoms. Now, this enzyme evolved in a world with very little oxygen, and the enzyme itself is very sensitive to oxidation. So only exists in organisms with low internal oxygen levels, like some bacteria, for example. Now, algae and plants evolved, and they produce oxygen as a byproduct of photosynthesis. We all know what photosynthesis is, right, Chris?
Yeah, that's when you take your photos to the chemist and they...
Maybe. I think you're showing your age about taking photos to the chemist. But
yeah.
I mean, we're talking about ancient biology here, so that's fine. Photosynthesis is the conversion of light energy into chemical energy. So plants basically turn light energy into chemical energy. They produce sugar. We all love a bit of sugar. And the atmosphere is much more oxygen-rich as a result of this process than when the nitrogen-fixing bacteria evolved. So
yeah, they absorb carbon dioxide from the atmosphere and turn the carbon dioxide into sugar and oxygen. That's basically happening there.
More or less. But yeah, so the sugar is essential for a lot of other life forms. The oxygen makes it difficult for some life forms to exist, including those nitrogen-fixing bacteria. But many plants can actually form relationships with these bacteria, and they create nodules on their root systems to protect the bacteria from the oxygen-rich environment. And they benefit from the nitrogen-fixing activities of the bacteria. Now, that seems like a pretty good symbiotic relationship there. And for a long time, scientists have been trying to develop the ability to get this symbiosis to form in other plants that can't do it themselves, especially looking at agricultural crop plants, which would then in turn reduce the need for excessive fertilizers, which, can have damaging impacts on the environment. There's a lot of, algal blooms and things that cause problems for human and animal health and environmental problems as a result of excessive use of fertilizers. But look, so far this hasn't been successful by traditional plant breeding methods or by genetic modification. But the concept is still being researched in other ways. So scientists at Nagoya University in Japan have been working on engineering nitrogenase genes, so the genes for that specific enzyme that can fix nitrogen, into cyanobacteria, which is a kind of pre-plant microorganism that's also capable of photosynthesis. So
well, that's your blue-green algae. You're talking about the algal blooms and things. That's your cyanobacteria right there.
yeah, some of them are known as blue-green algae, and they cause, all sorts of problems on their own. Now, some cyanobacteria are naturally capable of producing their own nitrogenase already, so other species are a good candidate for engineering to produce this enzyme themselves as well. So these scientists in Japan have successfully produced strains of a cyanobacteria called Senectocystis to produce small amounts of nitrogenase, but not enough to support growth without supplying them with other nitrogen, sources. Now, they hope to improve their success by enhancing nitrogen fixing ability by looking at other enzymes that might support those nitrogenase reactions, but also possibly adapting the nitrogenase enzymes to be more resistant to oxidization, which is part of the problem in getting them to sort of be stable and produce useful amounts of nitrogen. Now, they also think they may be able to engineer the enzyme to operate only during non-photosynthesis periods in other plants. In other words, they get them to work at night, so they put them on shift. Put them on shift work.
Hence the nitrogen.
Yeah, it puts the night in nitrogen there, I suppose. But that limits the exposure to oxygen because there's less photosynthesis, therefore less oxygen. Also, potentially focus production in root systems and other plant tissues where photosynthesis doesn't occur. The issue is that if, this is kind of highlighting the big problem with this research, is that the atmosphere itself is the source of the nitrogen gas that they use to fix the nitrogen, but it's also a rich source of oxygen, which then breaks down the enzyme. So it's kind of a kind of balancing act. You've got to remove the nitrogen fixing enzyme from the oxygen, but you've got to expose it to the nitrogen gas. So it's kind of a bit of a dilemma, and solving that dilemma will make this approach much more scalable and useful, and potentially improve agricultural efficiency in all kinds of crops if they can successfully pull it off. But I guess I can't finish this story without pulling out another possible irony. The main focus of this project is not actually to produce food for people at all. It's to grow feeder crops to produce bioplastics. So I guess, once again, any other benefits may be purely coincidental.
Science and technology must be absolutely mind-boggling.
Of course, it's mostly on the theoretical side.
Well, so far. Across Australia on the Community Radio Network, you're listening to Lost in Science.
All right, yes, you're listening to Lost in Science, and I'm talking about, mostly about near-death experiences, and you've probably all heard about these things or seen the movie Flatline.
Oh, I can do better than that. I've seen the movie Brainstorm.
Oh.
Which is a 1983 movie with Christopher Walken, who designs a thing that can record your thoughts, and he puts it on while he's dying. So that's the whole movie, basically, right there.
Okay, excellent.
Yeah.
But no, yes, like near-death experiences, people have known about them for a long time. They're fascinating, and of course they're quite controversial. I mean, a lot of people latch onto them as some sort of evidence of the spiritual world, or at least mind-body dualism, saying the mind is separate to the body, that there are paranormal phenomena involved with these out-of-body experiences, because people often talk about the idea that they leave their body and they float above it and look down at what's going on. And also, of course, there's hints at the possible afterlife because people claim to meet like either, angelic beings or loved ones who've passed away, this sort of thing.
So this is when, like people are having medical emergencies, right? And they're monitoring their life signs and they, like you say, they flatline and then they get brought back and their heart starts beating again and they're, they come back from what we would say is near death and are able to describe what they've gone through during that period between when they lose their life signs and when they come back. This is what we're talking about, right?
Yeah, like the classic scenario is like a heart attack, cardiac arrest, or something like that, and while CPR is being performed. And they're brought back, but the heart has stopped for a period of time, but then they are brought back from the brink, so to speak. Does occur in other situations as well. Like there's a variety of things that can affect people, I suppose. But also some of these experiences can occur in ways that I guess hint that it could be something that the brain is doing. That people experience similar kind of phenomena through, say, use of particular drugs or various other mind-altering circumstances. So this is, I guess, the other hypothesis, that it's purely something that is manufactured in the brain. But even if it is that, then it still, I guess, tells us something about how the brain and consciousness and the self works and how the human experience works in that sense. And this is one of the reasons why it's so fascinating, because it is this thing that happens, is happening more and more, I guess, because we have better medical technology to be able to bring people back. And so it seems like some of these big questions are accessible to science in this way. At least that is, I guess, the hope. But it does get tied up in the whole mysticism side of things as well, and makes it a bit more complicated. And I'll come back to that, because there is some important things I think to bear in mind when you think about how it interacts with that side of experience. But yeah, obviously the whole kind of paranormal aspect is really fascinating, and that's the kind of, I guess, the first thing that you might want to try and tackle. Like if people's minds are really leaving their body, then that tells you a lot about what's going on. So you may have heard about a study that was done a few years ago. I've seen the beginning of this study mentioned a lot, but not as much discussion of the results of it. It was called the AWARE study. It was done by a researcher called Sam Parnier from the University of Southampton in the UK. And what the idea was essentially was to have your ERs and put pictures on high shelves that you could only see if you were out of your body and floating around near the ceiling.
I love the design. This is one of those classic, elegant design experiments where it's thinking about how could you disprove it, I suppose.
Yeah. Well, that's it. That's the thing. It's one of those things where you think about that. And by the way, Sam Parnier does seem to be more of a proponent for, I suppose, there being some sort of spiritual side to things, from what I can gather from reading his work. But look. It does sound like an elegant experiment. Turns out it's not quite as simple as that, I suppose, when the actual results came out was not as, I suppose, impressive. So he involved 15 medical centres in the UK, Austria and the USA. And the results were published in 2014. Now, and like I said, it didn't really work, I suppose, in this sense. And they could, there's a negative result disproving the thesis, but essentially, in the centres where they had it, there are 2,060 cardiac arrest events. Only 140 people survived, and only 101 of those could actually complete any questionnaires on what they experienced. So out of those 101 patients, only 9% had anything that could be remotely classified as near-death experiences, and only 2 I guess describes seeing and hearing things going on in the room at the time. So that's 2 out of this original 2,060 kind of events. Of those 2 people, one of them then was too sick to basically be followed up too much and have more questioning. So you basically end up with 1 patient who was being able to describe what was going on. And what they reported was quite impressive. They didn't see any pictures because part of the problem was it was actually quite difficult to get the pictures in the right places in those rooms, and the room they were in did not have one of those pictures on a high shelf. Yeah, again, it sounds like an elegant experiment, but the practicalities of actually getting these things in place is a lot harder than you might think. But they did report things that were going on in the room at the time, and I think Sam Parnier gave it a very favourable kind of write-up in his paper, but one data point is not the most convincing thing for what sounded like a groundbreaking experiment.
Yeah, and you've got to sort of say, well, the statistical significance of one data point is not going to be great in proving or disproving anything, really, is it?
Yeah. Now, Sam Parnier then launched into kind of more rigorous study called AWARE-2. Now, the full results haven't been published. It was mentioned at a conference last year, I believe, and I found a bit of a few write-ups on it. But I haven't been able to find the actual work has been published anywhere yet in a peer-reviewed journal. But in this one, they were more kind of measuring, I guess, brain activity and people undergoing CPR. And they claimed to find some spikes of activity in the brain up to an hour into CPR, which is a lot longer than you would think, because the conventional, I guess, view was that the brain shuts down pretty quickly after the heart stops beating and oxygen stops being supplied. But like I said, the full details haven't been published in a peer-reviewed journal, but there has been some more related research published just recently. This is a different group led by Jimo Borgigan and her team at the University of Michigan. So they've been doing their own research along a similar vein. Now, in 2013, 10 years ago, they did some experiments with rat brains and found that they showed signs of brain activity, or the equivalent of consciousness in a rat brain, up to 30 seconds after their hearts had stopped beating. And so that caused a bit of a stir at the time, because it was kind of showing that there was measured activity in those brains. Now, the new research that's been published in the Proceedings of the National Academy of Sciences in the US has looked at human beings in this case. From what I can gather, what they've done, they've just looked at medical records. They haven't actually done their own experiment to, I don't know, test people as they're dying. They looked at people who were coma patients, basically, and they were on life support, and they had the electroencephalography caps already on them. Okay. And so they've gone back and looked at what happened there. Now, so there's only 4 patients involved in this, but the results are quite startling. So 2 of the patients, after their ventilators were removed, their brains suddenly lit up with a lot of neuronal activity in what's called gamma waves. So when you get an EEG, you get these, you've seen the pictures, I'm sure, you get these different waves of activity of electrical currents through the brain. Gamma waves are particular high frequency ones that are often associated with, I guess, wide connections across the brain. They're often activated when people are recalling a memory or learning or dreaming. And so there is some speculation they've got some sort of connection to consciousness. And so, yeah, it is really interesting that this is what was seen when the ventilators were turned off. They also saw particular activity in parts of the brain that are believed to be involved in consciousness again, and in dreaming and hallucinations and this sort of things. So it kind of suggests that there is something going on at this moment. And this is the kind of thing that perhaps could be then creating impressions, vivid impressions, because people, when report near-death experiences, they report this very vivid, lucid experience. And this is the kind of thing you might expect to see going on in the brain if this was happening. I should have mentioned the other thing to remember, though, with the activity, the reports of near-death experience, of course, is that they are clearly reported when people have recovered. We don't actually know when the event was experienced, when the memories were actually formed, whether they happened kind of during this moment of unconscious, whether it happened just after the heart stopped beating, or what happened. But I guess this is a good indication that there is this kind of furious activity going on in the brain at that time. Yeah, so, and as I said initially, it is also understanding how one of these things, they can kind of give us a clue to how consciousness works. In this particular case, you're actually looking at perhaps which parts of the brain, which kind of activity may be involved in these very extreme experiences of subjective consciousness. So look, it's fascinating stuff. Yeah, Jimo Borjadin, the main researcher, she thinks that basically this is part of a survival mode that the brain enters once it is deprived of oxygen, that it's basically getting its house in order, trying to just pull everything together and coordinate all activity across the brain when it's in this kind of threatened state. I guess that's a hypothesis for what could actually be going on there. But look, I think that's the thing to remember, and this is when it's saying how the mystical, I suppose, side of it is important as well, is that whatever is going on there, it is profoundly important to the people who experience these events. And it is something that, regardless of the actual mechanism behind it, is something that says a lot about human nature to people and is a very personal experience. In my reading for this story, I came across a paper about the lesser known unpleasant near-death experiences. They were talking about how people come to terms with those sort of events, and one of the strategies people might use is to say, oh, it's just a thing going on in the brain, and try and play it down. But this paper was trying to argue that in doing so, they weren't saying that's wrong. They're just saying in doing so, they are basically playing down, trying to reduce the severity of the experience in their own memory, but they're not coming to terms with the experience. They're just trying to deny it happened to a certain extent. So, yeah, as I said, it's an important thing to remember that these are profound experiences for people, regardless of how they're formed.
But it's interesting how much that comes up in, just in literature in general. I mean, you look at things like, the story of A Christmas Carol with Scrooge having, you could see that as a near-death experience, and it changes his behaviour and he becomes a better person as a result of taking that on board. So it's, if you do try and downplay it as, it's just something going on in the brain, well, everything's just something going on in the brain, really, isn't it? It doesn't really explain away what effect it might have on a person as a result of experiencing it.
Absolutely. And look, this particular kind of study, the nature of the ways they discovered does seem to suggest that they've got an element of, recalling memories, the whole life flashing before your eyes sort of thing, which, I mean, you brought up Charles Dickens. I think it's important to remember that a lot of our knowledge of this is shaped by movies and literature, and it perhaps doesn't happen in the montage you might see on a TV show. But it does seem to suggest that there perhaps is something going on, something that we could perhaps all look forward to. I don't know. Take it from what you will, whether it's comforting or not, but there is clearly something going on at these crucial moments.
And that's it for another episode of Lost in Science. Lost in Science is recorded for 3CR in Melbourne on the lands of the Wurundjeri people of the Kulin Nation, and it airs across Australia on the Community Radio Network with the support of the Community Broadcasting Foundation. We would love you to get in touch with us. You can email us at lostinsci@gmail.com, or you can find us on Facebook, we're Lost in Science on 3CR, or on Twitter, where we're at Lost in Science 1. You can find us on your favourite podcast app, where if you get the chance, please give us a good rating and review, as that will raise us up in the search rankings so other people can find the science. Or you can listen to us however you listen to us now, where at the same time every week, Claire, Stu and Chris get Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.